So to make it more quantitative, to determine which bond is this, what bond is this, polar or non-polar, you need to calculate the difference between two atoms. So if the difference is less than 0.4, this bond consider it to be a covalent non-polar bond, like between carbon and hydrogen, like between two fluorine atoms, or between two oxygen atom. So here we have a deal with equal sharing. They pull electrons equally, like two fluorine atoms do. Yeah, fluorine is very electronegative atom. Yeah, its electronegativity is the highest, is 4. But all fluorine have the same level of electronegativity. That's why the difference is 0. This bond is covalent non-polar bond. So another example, the bond between carbon and hydrogen. Electronegativity of carbon is 2.5, and electronegativity of hydrogen is 2 point 1. The difference between electronegativities will be 0.4, and that means that this bond between carbon and hydrogen still covalent nonpolar bond. Still covalent nonpolar bond. If the difference between electronegativities is more than 0.5, so let's say 0. More than 0.4, let's say from 0.5 till 0.9, 1.9, and in your book they mentioned 1.8, we can say this is only approximately. So in other sources it can be 2.0. Anyway, so if the difference between electronegativities is medium, this bond considered to be covalent polar. And what does that mean? That means that one atom with greater electronegativity pulls electrons harder from another atom with less electronegativity, and they create charges, but charges not like charges in ionic compounds when they lose or gain electrons. No, they still share because it's covalent bond, but the sharing is partial. Their charges are partial charging, and we will be using this letter delta, delta negative or delta positive. So the atom with greater electronegativity has more electrons near its atom. That's why the density of electrons greater around its nucleus. So this atom will be partially negatively charged, and another one, like hydrogen here, will be partially positively charged. So if the difference is more than 2, it's going to be ionic bond. Now let's do concept checking. So when can we use delta positive and delta negative? When the bond is covalent polar bond, not ionic and not covalent nonpolar bond. When the delta of electronegativity is from 0.4 till 1.9. So this symbol is delta difference. And this delta is small, partial, means partial charge. So Yes, and we need to remember these intervals. So 0 to 0 0.4, from 0 0.5 till 1.9, and from 2.0 and higher. Which covalent bond is polar, CH or OH? Show calculations and label polar bond. So what you're gonna be doing here? So you need to use the table with electronegativity, and you will calculate the difference. So delta En. For a carbon it's 2.5, for hydrogen mm, 2.1, and we calculate this electronegativity difference, and it will be 0 0.4. That means that electronegativity uh, small enough to consider this bond as a non-polar bond. What's about the bond between oxygen and carbon? So electronegativity or between oxygen and hydrogen. Electronegativity of hydrogen is small, 2.1. Electronegativity of oxygen is 3.5. So the difference between them 1.4. So we label this bond as a polar bond. So exercise number 3, complete the table. And what you need to do here. So you need to use delta plus and delta minus symbols, and you need to use a charge with electronegativity values, and you need to show where is partial negative or where is partial uh, positive charge. So here, this type of bond between silicon and hydrogen, the difference is 0 0.4. That means that this bond is nonpolar. If this bond is nonpolar, so they're sharing equally. And how do we show this bond? We show this bond nothing to symbols. So no partial charges, because this is non-polar bond, or you can use 0 and 0. Let's do another one. So bromine and bromine, the difference is 0, so the bond is non-polar, equally sharing, and this bond we consider it to be non-polar. That's why no charges at all. So the another one, hydrogen is 2.1, and chlorine is 3.0. You are always going to subtract a smaller number out of a larger one. So 3 minus 2.1 gives us 0.9. So and this bond will be a polar bond, because difference is greater than 0 0.4, so it's polar bond. If it's polar, so sharing is unequal, and we show this bond like this, H and chlorine, and we will use partial charges symbol. So for chlorine, it will be partial negative because delta negative because it has more electronegativity level, and for hydrogen, it will be partial positive or delta positive because its electronegativity is smaller than electronegativity of fluorine. And when we imagine this molecule hydrogen and chlorine bonded together, we need to understand that near to the chlorine it will be more electron density than around the chlorine, the hydrogen, I'm sorry. So the next one, magnesium and oxygen. So magnesium oxide, the difference of electronegativity is 2.3, so that means it's ionic compound. It's not sharing, it's transferring of electrons. So magnesium loses its electrons, and oxygen gains electrons. So for magnesium and oxygen, pay attention, guys, no dash, because dash symbolize covalent bond. There is no dashes for ionic compounds, and we use not delta positive, we use just charges, because magnesium lost 2 electrons, that gives magnesium the charge, the real charge, 2 plus, 2 positive. And the next one, nitrogen and hydrogen. The difference between electronegativities is 0.9. That means that this bond is polar. So it's sharing because it's covalent bond, but sharing is not equal, it's unequal, and it's gonna be charges. So for greater electronegative element like nitrogen, we will use delta negative and delta positive for less electronegative atom like hydrogen. So the next one. Carbon and fluorine. Carbon has electronegativity of 2.5, but fluorine has 4. So we at least have a difference 1.5. This is a huge difference. So that means that this bond is very, very polar. So it's still not ionic because it's less than 2.0, but it's very polar. It has unequal sharing, and partial charges will be partial positive, delta positive for carbon and delta negative for fluorine. And this arrow shows that these shared electron pairs goes closer to fluorine, and the density of electrons around the fluorine nucleus will be more than around the carbon nucleus. So the next one, oxygen bonded with hydrogen, the same. So difference 1.4, polar, unequal sharing, and so on.